In this exercise, we have a hypothesis test concerning two proportions. We want to compare the successful rate of challenges by men in tennis matches to the successful rate of challenges by women in tennis matches. And you can see for the men that out of 1,396 challenges, 429 were overturned. And for women, out of 740 challenges, 230 were overturned. We want to use an alpha equals 0.01 significance level to test the claim that men and women have equal success in challenging calls. Okay? Equal success, that means we're simply comparing whether or not they have the same rate. We're not saying that men have a more successful rate, nor women have a more successful rate. So we're just saying that we think that the proportion of successful challenges by men is equal to the proportion of successful challenges by women. And then the alternative would be that they are in fact not equal. So I've transferred the necessary information into Excel. I have the number overturned by men compared to the total number challenged by men, overturned by women compared to the total number challenged by women, and I need to go ahead and calculate a sample proportion for each of those. So here I have my p hat for men, the successful challenge rate for men, which is just x1 divided by n1, and I have the successful challenge rate by women, which is just x2 divided by n2. I've also gone ahead and noted my hypotheses here. The null hypothesis was that they have equal success rates in challenges, and the alternative was that they do not have equal success rates. Let's go ahead and note that alpha was equal to 0.01 for our particular test. Okay, let's go ahead and now get into the calculations. In order to do this, you'll notice up here in the formula for our test statistic that we need a pooled proportion and then its complement. So let's go ahead and calculate that. You can see right here I gave you the formula for the pooled proportion. It's simply the sum of x1 and x2 divided by the sum of n1 and n2. So we say p bar is equal to the sum, and notice I'm putting the sum in parentheses because if I don't, the division will occur first, and that's not what we want, divided by the sum of the sample sizes. So there's my pooled proportion, and then of course q bar is just equal to 1 minus my pooled proportion. I now need to calculate my test statistic. Now there's something I want to note up here in the formula. You can see in the numerator that I'm doing the difference between sample proportions, and from that I'm subtracting the difference between assumed proportions. But if I'm assuming the proportions to be true, which you can see over here in the null hypothesis, right? I'm assuming P1 equal to P2, then this would be 0, okay? So all I'm really going to have in the numerator is the difference between the sample proportions. So let's go ahead and calculate my test statistic. So the z-score is equal to the difference between sample proportions, right? P1 hat minus P2 hat divided by the square root. Again, remember the reason that I only have those in the numerator is because I'm assuming P1 equal to P2, so P1 minus P2 would be 0. So divided by the square root of the pooled sample times its complement divided by n1, so p bar times q bar divided by n1, right? Plus the pooled sample times its complement divided by n2, so p bar times q bar divided by n2. Square root of that whole thing, and that's my test statistic. So it's relatively close to 0, which means there's going to be a fair amount of area left of it. And then it's a two-tailed test, so I'm going to double that when I calculate the p-value, right? So I'm expecting, again, I was talking earlier about using our intuition, I'm expecting to fail to reject H0 here. Okay, I'm assuming there is not good evidence that they differ in success rates. So let's go ahead and test what I had just said and calculate our p-value. It's a two-tailed test, so I'm going to go ahead and double the probability, the area that I'm about to find, and I'm finding the area left of my z-score, right? And I'm using norm.dist because it's a z-score, it's standard normal curve, right? So area left of negative 1.6. So here's my x with a mean of 0, standard deviation of 1, and I want a cumulative area. Right. So there, my p-value is 0.8675 to 4 decimal places, which means that you're going to see this, right, the vast majority of the time. If their proportions are in fact equal, then it was very likely to see this small difference in the two samples that I saw. That's what our p-value is telling us. So we're going to fail to reject H naught because our p-value is significantly larger than alpha, right? So we'll go ahead and note that in this case, failing to reject the null hypothesis means that there's insufficient evidence to conclude that men and women differ in challenging calls in a tennis match.